Welcome to the Printed Circuit Podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. Over the last few months, we've been talking about some important elements of modern PCB design. We've covered how today's software needs to be intuitive, how AI can be and should be part of the PCB design process, and the importance of the integrated tools and systems, specifically PLM integration. Joining me today is Paul Welch, Product Manager with Siemens, to discuss the importance of secure, remote, and collaboration capabilities in today's PCB design flow. Paul, thanks for being here with me today. Can you give our audience a brief introduction?
Great. Thanks, Steph. Glad to be here today. Yeah, my name is Paul Welch. I'm a product manager for Siemens EDA. I work primarily on our cloud-connected solutions.
Awesome. Let's just dive right into it because it's such a good topic. The first thing I want to come out of the blocks with is, how has cloud connectivity transformed PCB design collaboration in recent years?
I think the biggest factor is with the recent shift to remote working. A lot of people working from home. Teams are distributed globally. And so the EDA tools need to provide this digital-first approach to support this new way of working. And the cloud is enabling that transformation. So let's take design review as an example. Teams are no longer doing design review all at once in a conference room. They're working in different time zones, and they need tools to help support these asynchronous design reviews with more of a anywhere at any time approach. So moving the design review process to a centralized cloud environment enables this, where versioning ensures everyone knows where to go to see the latest iteration. Team members who don't have access to the design tools can still visualize design data in 2D and 3D, provide feedback, and that feedback for all the stakeholders is captured in a centralized location. Workflows can then track the status of changes going into the next iteration based upon that design review feedback. And you get full design history, traceability. So this digital transformation enables teams to be more efficient in design reviews and reduces the chance for introducing errors into the design.
You mentioned 2D and 3D visualization. Can you walk us through how web-based 2D and 3D visualization works in practice?
2D and 3D visualization is a game changer for teams. As I mentioned earlier, for reviewers who don't normally have access to the design tools, web-based 2D viewing allows these users to view the schematic and the layout at the same level of detail as if they were using the design tools. They can view the schematic and the layout concurrently or side by side and cross-probe between the schematic and the layout on components and nets. So that really provides a nice intuitive way to interrogate, review the design, and get into see where you need to find potential issues. So with 3D visualization, that provides more of a physical view of the PCB layout. And that's really good for reviewing mechanical aspects of the design, how it's going to fit into the package.
What specific features enable remote design reviews to be as effective as in-person reviews? Because when you think about collaboration, especially on remote teams or in today's environments, a lot of design engineering teams are scattered globally. So elaborate on this a little bit more for us.
Yeah, and that dispersed team, that's really where cloud connectivity comes in to help. Having everything happening, the design review activity happening in a single kind of unified or centralized environment is really helpful. So take the 2D schematic and PCB viewing that we just talked about. With that, reviewers can inspect the design down at the net and part property level, like I mentioned, which enables them to check for connectivity, component placement issues, and other issues with components, right? So when potential issues are found, reviewers can capture that while they're reviewing the design. So they can actually, annotate the design that they're viewing, add the issues that they're seeing or potential issues that they're seeing, and get it captured into that project. And so this is really sort of the in-person equivalent of redlining or marking up. Or if you remember back when everyone was in a room, you might have a drawing sitting on the table and people are marking up or redlining, right? So it's sort of the digital equivalent of that. But the benefits of doing it in a cloud-connected environment are far greater in that everyone's feedback is captured in a single location. So it's all centralized, and who created which issue and when. Also, each issue can have status assigned to it. So now that really enables teams to help manage how each issue gets dispositioned or addressed in a particular design iteration. So all this provides more of a systematic approach to design review, with more control, traceability over issue tracking to make sure that everything's addressed before you release that board to production.
What I really like about this is the fact that you're getting this real world instantaneous feedback and traceability to be able to know when you look back, how do we get here? Or what was the decision factor that led us down this path? And the traceability of being able to collaborate from multiple sites, or even if you're in the same building, you don't have to be in one room. You can be in multiple cubes or on the other side of the ocean across from each other. It's truly amazing when you think about the evolution of this cloud-based connectivity. But this leads me into how does the bill of materials factor into the design review process?
Yeah, the BOM is critical to the design review process, right? And this is really one area where adopting a cloud connected solution can really pay off in that with now connections into supply chain status and data streams, right? You can get near real-time insights on the health of the BOM, which is really important as you start and go through the iterations of your design cycle. So any component that's high risk due to either life cycle, pricing, availability can get flagged right away. And you want to see those as early as you can, right? And so I think it's well understood these days that teams really do need to have these insights as early as possible in the design cycle to weed out those high risk or problematic components before getting into manufacturing.
When you talk about left shifting that intelligence, that supply chain intelligence that in the past, in the legacy processes, was external to the design process. Now we're bringing that intelligence to engineering for the entire engineering team to be able to work efficiently and effectively on the fly to make intelligent decisions. So that way, when you're finished the design, you don't have to worry about doing a BOM analysis and being shocked at what the results are going to be. And that will cause you to go back and redo potentially a total redesign because, part availability is just not there, or how part scheduling could affect your project timeline.
That's exactly right. Yeah.
My next question to you would be is when you think about accessibility from that external information, that supply chain information, when you think about supply chain resilience, how do you balance accessibility with security in cloud connectivity or cloud connected design? Because security and IP is extremely important, especially when you think about the enterprise level, like mil-aero industry, for example, it's a huge factor and a huge concern when you think about securing your IP.
That's right. That's a really good question. We talk about this a lot with both internally and with customers, right? And you're right that the IP needs to be secure. Many customers are used to keeping that data on premises, right? That makes a lot of sense. Although when you need to collaborate, again, back to this new realm of remote teams and distributed teams, collaborating with external partners, whether those are design partners or outsourced manufacturing partners, having the data constrained to on-premises only does create some challenges around how do I collaborate and get everyone else to review that design. So when it comes to security, right? Secure by design, which is a term we use, is a practice we follow at Siemens EDA, where security isn't an afterthought. We don't develop a product, then think about security. It's baked into every step of our development process, from early planning, architectural design, all the way through development and delivery. We're always thinking security through all the steps of when we develop a product or a feature. Further to that, our philosophy is that every Siemens employee is responsible for security. So everyone needs to be trained on the latest trends in security, as well as, understand as we're working out how to develop a feature or new product, what does that mean from a security perspective? So that's always top of mind. But we also want to make sure our products provide a great user experience and our customers can easily manage, access, and collaborate on their design data, right? We don't want to make it too challenging or difficult, enable collaboration. But it's not always easy to strike that right balance. So we do invest heavily in user experience. And I'll just give an example, right? We focus a lot on these workflows around user authentication. So how does a user set up their account? How do they sign in? How do they set up their multi-factor authentication, which is another additional layer of security, as well as how they get in and manage the account security settings. And we want to make all that intuitive and easy to use.
I've worked on many teams where I had international team members, so ITAR restrictions, and you had to really curtail or lock down on what data was accessible to who and which team members. And so assigning roles to specific team members was very important and extremely critical to who can access what data and where. I mean, I remember there were times where I would travel to India, and because I'm located in India, even though I'm a US citizen, I could not access the data because of the location of where I was at. It is very critical when it comes to managing that IP, not just who has access to it, but from where are you accessing that data? I can attest to that from my experience. With that, what measures are in place to protect, intellectual property during collaboration? We talk about teams collaborating most effectively and efficiently. What measures are in place?
Yeah, another great question around security and access control. So let me first talk a little bit about how remote design collaboration may have happened in the past, right? And this, we know this too well, right? This is probably done through anything from emailing files around, PDF outputs and exports of your design, potentially providing your external partners temporary VPN access, which many IT organizations frown upon today. So that might be a challenge that we get a lot of feedback around that no longer being a viable option. Or using some free cloud file sharing tools, which they also apply security, but when you're not paying for something, your service level agreement is not going to be the same, right? And so the risks around this are, in my mind, are twofold, right? One is as you iterate on your design, you're creating new versions and making changes. It's really easy to lose track of which one's the latest that I got email that's sitting in my email box. And then you don't want people reviewing or making changes to the wrong version of the data, right? So that's a big risk in terms of just not having a very controlled process for how you're sharing data. The second one is once you send that out, you kind of lose track of what happens to that data, right? You don't know if that person who received it is going to pass it on to somebody else, maybe even inadvertently. And so having that sort of uncontrolled method is really, you lose traceability over where that data is going. So in contrast with the secure cloud environment, right, each customer operates within an isolated cloud workspace. And initially, when the account is first being created, only the customer-defined administrator has access to that workspace. So they go into the workspace first, configure it, and then that administrator actually decides who gets access to that workspace as well as the data within it. And then if the design data itself is stored in individual projects within that workspace, and there's sort of a second layer of access at the project level where for each project, you can define which workspace user can access that particular project data. So those are two layers of access control. And the real advantage to that kind of access model is the administrator will always know who has access to the workspace, to individual projects, and at any time they can remove that access, in which case that data is no longer accessible to that person. And I guess the third layer is role-based access control, right? So in addition to all the security, standard security, and access control, the admin can define each user's privileges based upon what tasks they need to complete. So for example, in a design review use case, that user might need read level access and have the ability to provide feedback like what we talked about, where they can add markup annotations, find issues. But maybe that user doesn't need to download the data. So you can control that privilege, or you don't want them to modify the data in any way, or don't want them to upload any other files or external content. You have that full control with role-based access control. So in that model, right, your team gets the access they need to complete whatever task it is they have to do. But you as the administrator, the person who's really concerned about the data, the security aspect, you now get more control, visibility, and traceability over who has access to that data.
When I really think about security, whether it's cloud-based connectivity, just security of IP in general, I think of it like an onion. It's got many layers and it's got to be resilient. And so what you described is truly the evolution of where we come from, of how we used to just put stuff on a server and, oh yeah, just leave that alone, just verbally, and the potential of getting things wrong or fabricating the wrong board or making inadvertent changes or unfortunately deleting something that wasn't a file that was actually the released file, and potential for catastrophe or devastation to happen. When we talk about losing data forever or data being compromised is critical.
It's a very important topic, right? I mean, it's, every customer we talk to, it's always top of mind. Kind of the first question we get is questions about sort of our security, compliance, the protocols we have in place around how we operate our cloud solutions, how we develop them, and how we build security into them. And further to that, I think if there's ever a need to kind of look a little more deeper, Siemens has a great trust center, right? Our website that goes over not only security, but data privacy, as well as our service level agreements with our cloud solutions. So a lot of good resource there on our trust center.
When you think about the industry standards that are out there that are common standards such as ISO/IEC 27001, which is information for security management, IEC 62443 for industrial automation controls, there's NIST cybersecurity framework and common criteria, standards for evaluating, security. And then you have the industry specific DO 254 for aerospace, ISO 26262 for automotive, IEC 60601 for medical devices, and MIL standard 883 for military applications. There's a lot that you have to be aware of when you talk about security protocols and securing your IP. With that said, I got one more question that's fitting to ask is, where do you see cloud connected PCB design headed in the next few years?
This is always an interesting topic too, right? I mean, I think it's no surprise that would be AI technology, based technology is sort of where things are headed, right? So just like everything else, Gen AI, agentic AI, right? They will play a bigger role in how teams collaborate. And so our approach, our perspective is, as we look at AI technology, we view it as another tool that we can implement that helps our customers be more efficient and effective across all the steps of the design lifecycle, whether that be in the design process itself, in design review, as we talked about, or analyzing supply chain situations on the bill of materials. There are a lot of ripe opportunities for leveraging AI to help streamline and make those processes a lot more efficient. So if we take design review as an example, right, it's possible maybe in the near future actually, that a design engineer can leverage an AI agent to collect, analyze, review feedback, and provide recommendations on the next iteration based on all the design review feedback that people have given for that particular iteration, right? Including cost impact or maybe other impacts in manufacturing, design for manufacturability, and so forth. Or perhaps use it to help manage and track outstanding issues or defects from design reviews, right? So you can imagine for larger teams or more complex design projects, there could be a lot of design review feedback coming in for any particular iteration that you end up with sort of a backlog of a lot of issues. And rather than, having to work through them and manage the status and tracking and all those workflows around dispositioning and addressing all those issues, perhaps an agent could help at least bring in and analyze the situation and help you understand a better picture of what does all this feedback mean? How do I prioritize it? Which ones should I address first? And sort of what's the impact, right? So those are the areas where we think we can leverage AI to help empower engineers to be more productive and focus more on the core design work and less on the tasks that aren't as fun.
You mentioned AI and with the evolution of in the industry and where it's unfolding and how it's unfolding, there's a lot of hesitation or a lot of concerns out there, especially people thinking that AI is going to take their job. But in many cases, in almost all the cases, I should say, AI will just be a tool that the engineering teams will leverage to their advantage to produce better quality product and faster, because AI agents are able to do things that would normally take us significantly amount of time to go research and do, and the AI agent can do it extremely fast and very efficient. So when I think of engineering teams leveraging, it's just going to make engineers just that much better, and the end product that we're producing that much better, as well as the controls of our product. When we think about controlling our IP.
Yep. Yeah, I agree.
With that, I think we've covered the importance of secure remote collaboration capabilities in PCB design tools. Thank you again, Paul, for joining us today. And thanks to our listeners for tuning in. I highly recommend joining us for future episodes, exploring trends, challenges, and opportunities across the printed circuit engineering industry.